So if you guys are new to AWC, it stands for the Association for Women in Computing. We're a group that's excited and basically just all about supporting women in tech, but you don't have to be women, you don't have to be in tech to join our club. We welcome anyone from any major and any gender. We mainly hold meetings every other Thursday from 6 to 7 over Zoom. They're mainly technical workshops where you guys can get hands-on in technologies and tools, and they're mainly supported by our company partners. So today we have Qualcomm teaching us all about Unix and optimization. So please make sure you hit that link and sign in so they know that you've been here. If you want to learn more about AWC, join our listserv, check out our website, awc.org.bt.edu, and follow us on social media like Facebook, Instagram, and Gobbler Connect. So just to let you guys know, we have this fun incentive for all of our members. So for every single meeting you go to, you'll be entered into a raffle, and they'll pick 2 lucky people to get $10 gift cards each, and we'll let you know via email if you won. And 2 weeks ago, I think we set up an opportunity for all of our members to attend GHC, which is virtual this year. So thank you for everyone who applied. It was a very competitive pool of applicants. So thank you so much for that. It was hard to pick only 3, but these were the 3 winners that were able to go to GHC. I think it's happening right now. So good luck to all of them. I hope you guys are enjoying it. And thank you everyone who applied again. If you weren't able to get this opportunity, don't worry. We have a bunch of other things coming up this semester. So that includes the WE 20 scholarship. So this is SWE's national conference. So it has a bunch of opportunities. Like I think there's around 200 sessions where you can attend talks that are company-based or about like higher education opportunities, or the keynote speakers. There's also a 4-day career fair, so you can network with a lot of companies. This conference is more general to engineering and overall, so it isn't computing based, but there's a bunch of big names like Apple's there, Google's there, Amazon's there. So there's definitely a lot of tech companies there, and you can get those amazing opportunities. So in order to do this opportunity, make sure you apply by tonight. We have a forum that's set up, so make sure you apply, and we'll let you know by tomorrow if you got in or not. And it's, I think, for 2 weeks. And make sure to check out their website if you want to learn more. It's on the slide right here. So check out we20.swe.org if you want to learn more about the opportunity and be involved.
All right, hi guys. My name is Mia. I'm one of the vice presidents, as Priyanka mentioned. I'm going to talk about 2 hackathons really quick before we get started with our Qualcomm content today. The first one being the ELC hackathon, as in Estee Lauder, yes, the beauty company. They are having a virtual hackathon from September 24th to October 8th, so it's going on right now. And the target is to make some kind of solution to help the fight against breast cancer. So you can go to the link right there to see how you can get involved with it. Our past president of AWC is working there currently as a business analyst, I believe. And she's very passionate about the company and this event. So I recommend checking it out at elchackathon.com. Then our next one, talked about this last meeting, so I'll keep this short. Technica is open. It is the all-woman non-binary hackathon hosted at University of Maryland. It is huge. I highly recommend checking it out at gotechnica.org. It's going on at the end of the month. And it's sponsored by MLH, which is Major League Hacking, the big hackathon organization. So it is a big deal. Okay. Anybody have any questions about the raffle, which we'll put the link in at the end of our meeting? Grace Hopper, ELC, Technica, or anything else AWC related?
Feel free to put it in the chat or unmute yourself, whatever you prefer.
All right, well, if you don't have any questions right now, feel free to put them in the chat throughout the meeting. Me and Priyanka will be monitoring the chat throughout the whole time. And for now, let's transfer control to Qualcomm, who's talking about Unix and optimization. Do we have Katie here today? If not, one of the other Qualcomm representatives is talking.
Hey, yeah, I'm here. I think Katie should be on.
Yeah, sorry, I was on mute.
Oh, there you go.
Yeah, let's see. share my screen. Okay. Are you all able to see the please check in slide?
We see the presenter view right now.
Okay. There we go. That should be better, right? Okay, cool. So I think you guys had this up already at the beginning of the meeting, yeah? Okay, so if anybody didn't sign in using the Jumpstart link here, just take note of that real quick. That just helps get you like logged into like the Qualcomm system just so that they can record that you've come to some of their sessions and events and kind of keep track of things that are going on. So have our fancy Qualcomm. Welcome to the Invention Age slide. So little intro first. My name is Katie. I am a tech alum. I graduated in May of 2019 with a bachelor's in computer engineering and a minor in computer science. I did 2 internships at Northrop Grumman and then 2 internships with Qualcomm. And now I've been working full-time for a little bit more than a year at the Boulder office. I'm on modem software team. So that's what I do. And then TK can introduce himself.
Thanks, Katie. My name is TK. Currently, I'm also a grad from Virginia Tech. I graduated May 2017 with my undergrad, and I graduated May 2018 with my grad school degree. I interned at Qualcomm the summer of 2017, and then I also interned at Intel, and I did research for one of my master's research for one of my summers. I've been doing full-time at San Diego at Qualcomm for about 2 years now.
So first off, we were going to start with telling you a little bit about Qualcomm before we get into all of the Unix fun. Qualcomm's not necessarily like a company that lots of people know much about, so wanted to cover that. So they've been around for 35 years now, and really one of the forefront companies in terms of like wireless and making modems, semiconductors, all of that good stuff. We're the #1 fabless semiconductor company, and what that means is that we create the designs and do like the engineering design for all of the different chips, like the modems, but we don't actually have a manufacturing plant ourselves, so that's the fabless part. There's nowhere where we fabricate them. We send them elsewhere to be made. And fun fact, looks like we were one of the 2020 world's most innovative companies, so that's pretty cool. Lots of up-and-coming tech here.
This is more of just a history of how Qualcomm has led in different areas throughout the past couple of years. So in the last 30 years, it's been digital communication, things like phones, and just being able to connect people. Right now, we're very focused on leading in computing on smaller scale, everything from smaller scale phones to large scale servers and things like that. We're trying to expand in cars and all these other things, trying to expand into these different environments and get a leadership position, as we have a good portfolio of things that help us do that. And then in the next 30 years, everything is going into basically overall industry, just trying to get everything connected. And if you heard about 5G specifically, just trying to make sure everything can connect to each other, everything can communicate with each other at speeds never before seen. And we're currently leading in that as well, just trying to get the entire world interconnected.
So here we have just some different examples of things that might be connected with the 5G, like TK was talking about. So there's a lot of different circles, if you can see them highlighted on the slide. I'm not super sure what all of them are supposed to do. Like there's this little fun robot dog looking guy, not sure what he's doing, but all sorts of things that will be connected in the future, from like stoplights that can communicate with the cars that communicate with other vehicles, drones, and then you also have the aspect of people themselves communicating. So whether that's like the typical emails and like sharing data and things like we talk about now, or other things that I can't even imagine yet. There's just going to be a lot of different opportunities that'll be available in the future.
This slide basically just goes over the two aspects I was talking about before that Qualcomm really tries to be a pioneer in, and that's connectivity, being able to connect people from all around the world or just right next to each other, and then also processing. So not only being able to do everything with low power, but able to process things at much faster speeds than our competitors, or with a much better output compared to many of our competitors. And this goes into a lot of things like the CPU, GPU, DSP. All these things are built in to our, this is the 855, but we have now the 865 and all the newer chips that are coming in, and just trying to focus on making sure it's the best it can possibly be for that current generation.
And I think this slide too is kind of cool for showing like all of the different things that you could be involved in here at Qualcomm. So like both TK and I work with the modem, so we would probably be more on the connectivity side, but there's lots of people that deal with more of like the power management, the signal processing and stuff like that. So even if you think Qualcomm and hear us talking about like wireless technologies and stuff and have like no idea what that even means, because I definitely didn't when I started working here, there's still lots of opportunities and things to explore, so don't let that stop you. This one is just kind of another example of some of the things that Qualcomm has had a hand in that you might not necessarily think about. A lot of these, like taking pictures on your phone, streaming videos, always having internet access, are things we kind of take for granted nowadays, I think, because we're so accustomed to them. But they wouldn't really be possible without the different capabilities that are a part of the smartphones, and a lot of that comes from the chips that Qualcomm makes.
And going off of what Katie said before, this is a good example of how Qualcomm does things that incorporate a lot of different areas. So if you think, oh, Qualcomm's only a hardware company, they only make chips, there's a lot of things that those chips go into that we also need to test to make sure they work for. A lot of different groups and different fields that it has to work for. So in these, you can see different examples of where Qualcomm chips are used and how they're helping people, and how they're helping people now and will help people in the future for a more futuristic type tech. We have a goal of powering over 12 trillion different devices in by 2035. So especially with our 5G leadership going in right now.
And just another slide. We didn't make these parts. These are some of the like recruiting, marketing things, but more evidence of how 5G and artificial intelligence will really get everything connected together in the future, and just touch on a lot of different pieces of our daily lives. And it's going to be a lot of data to be transmitting around. So being able to create devices that can, transmit that data using less power, do it more efficiently, will really help with getting all of the different things connected.
And same thing with AI. A big part of the importance of 5G is the increased speeds that they bring in. And with that increased speed, you means more data is traveling through, and that allows for faster processing. So rather than having your phone do everything, you can offload it to another server, and that happens much faster. And this is where that AI drive will come from, being able to do much more logic seamlessly on your phone or whatever device you're using, and being able to incorporate that by not having to be limited by what hardware you have in your hand, but what's around you, and all the other things that make up the sort of ecosystem that's going to be generated from this new layers of technology that's being developed.
And here you kind of see some of the like future visuals that they're anticipating for the automotive side of things. You can have a lot more like personalized settings for how you want to have your like driving experience in the car, as well as being able to monitor like both what the driver's doing. I think you could probably be able to like tell where people are looking and whether they're actually paying attention to the road. I know already some cars have the ability to detect if like you're holding the steering wheel or not. So kind of taking all of those detections further, as well as paying attention to like the surroundings outside of you, whether there's heavy traffic, your turns are coming up, lights, all the cars. So really just being able to take that further and making it more mainstream in the future.
Another area this is leading towards is virtual or cloud gaming. Basically the ability to play games anywhere. You've seen probably commercials for Google Stadia, or NVIDIA has their own system for this. PlayStation has their own system. So this brings in better latency and easy access to multiplayer gaming. And you can enter games faster, distribute the workload for the game, and basically just process everything better with better graphics. So again, by offloading a lot of that work. And this all requires a lot of throughput, a lot of data to be pushed through. And with this new era of 5G and other systems around that, being built around that, where it's much easier for us to get to that level where we can do this virtual / cloud-based gaming.
So basically, if you haven't figured it out by now, with us talking about all these different things that are coming along, mobile is pretty much impacting everything in our daily lives, and I think that's only going to continue to grow. So now we'll move from Qualcomm specific into the Unix related side of things, more of the workshop. And today we're going to talk to you kind of about some of the basics of Unix, as well as how it can be used to do some optimizations and parallelizations. So those are what we're planning to cover. So first off, I wanted to start with a little bit of history of what is Unix and how did it come to be. So Unix is a multitasking, multi-user operating system. In the late 1960s, early 1970s timeframe, it was developed at the AT&T Bell Labs. Originally, it was a licensed product and had more of a use case for academic and research purposes. The big draw of Unix in the first place was that it was an operating system that could work over many different hardware architectures. So previously, if you had your operating system, chances are it could really only run on one specific hardware, like computer design. But with Unix, they were able to take the same core operating system and move it across a variety of hardware architectures. So that was really useful because it saved you time, saved you money, and you didn't have to like go and relearn how to communicate with your computer every single time there was a new computer. So people got more used to it, decided it was indeed useful and something that they're wanting to be more instances of. So then in the 1980s, GNU, which stands for GNU is not Unix, so it's a little bit of a recursive name there. They started working on getting out a free equivalent of Unix, but the problem for them was that they didn't have a kernel to run it on. So they had their tools that they were working on developing, but without a kernel, there was no way for them to really like run and verify them and make an end-to-end product that they could deliver. So then in the early 1990s, this guy named Linus Torvalds, some of you might have heard of him. He's definitely kind of a popular person in the computer world. He was able to develop the kernel to actually run the GNU tools on. So in partnership, he was able to release Linux under GNU, which is pretty much what everybody thinks about now when you think of Unix. They tend to be synonymous in name, even though one is more of a system and then one is like a subset-ish type thing. But since the advent of Linux, everything like the use of Unix has really exploded and grown in popularity. It's the base for a lot of different supercomputer platforms now, modems like what we develop, different mobile devices, and just pretty much a lot of the tech that you can think of is going to be using the Unix or like a Linux-based subsystem. So I have some different examples here just listed out, things that you probably heard about before. Red Hat, Ubuntu, Debian, those are all different flavors or distributions of Linux. Mac OS is also based off of a Unix design. Android is running Linux on it. The Raspberry Pis, they run Debian, so a lot of the different IoT projects, you're going to be using like the Unix concepts, but the Linux flavor. And really what has made it so popular to use is that companies are able to write one device driver and be able to run the same device driver across multiple devices without making, or they might have to make some changes, but they'd be a lot more minimal. And that kind of goes back to that same idea that you could have your one operating system and it has this common kernel, and then you can make small tweaks as you're moving it to different hardware architectures, but overall it's roughly the same. So it saves a lot of time and money and design complexity there. So now a little bit more about the actual characteristics of Unix, what makes it special. So like I mentioned, it's an operating system, and there's three main parts to it. So there's the kernel, the shell, and programs. So the kernel is what actually allocates the time and memory to the programs and handles the system calls that are being made. The shell is the interface between the user and the kernel. So this would be like the command line interface, and that's usually what you think of, when you open up your command line and what you're typing in, that's going to be the shell that's acting as that interface. And then there's the actual programs, which are the commands that you request. So I put up an example here to kind of illustrate how all of these things are working together. So say you wanted to remove a file from your computer. You would pull up your command prompt. You would type in the command rm, which is what you use to remove things, into the command line interface. Then the shell would actually go and find the file that contains the program with the instructions for whatever rm is supposed to do. And then the kernel is going to handle the request to actually execute that rm program. So that's kind of how all the pieces work together. Another characteristics of Unix is that everything is either a file or a process, and that makes things a lot simpler with what you're dealing with. So the process is just the executing program, so that would be like the RM that we talked about before, removing things. And then a file is just a collection of data, and in Unix they're treated as byte arrays, which makes it a lot easier to develop different tools that interact with the files, because you don't have to worry about like, oh, does this file have this design where it has like a header and then the data and then a footer or stuff like that. It's all just one array of bytes, so you can traverse through that array as you need to. So that makes it easier to manipulate things and execute whatever you're trying to do. Another feature of Unix is that it has a unified file system. So what that means is that it's organized with a hierarchical directory structure. So if any of you have ever played around with Linux, you might have noticed when you first log into the system, it usually will come up in the root directory, and that's kind of like the overall directory that everything stems from. So from there, you're just going to have however many folders, subfolders, things laid out as you want to, but you can, all of that can be accessed from that root directory. And if you look at your Windows machines, they have the concept of drives. So like I have a machine that has a C drive, a D drive, there's like an H drive, all these sorts of things that you can't necessarily talk between the C and the D drive. So having that common unified file system allows programs to talk to each other more easily. And I mentioned here shell scripting, the command language. That's just kind of the idea of combining those different commands. Like you would be typing in yourself to the command line interface. You can also combine those into scripts to create more complex programs that are running and executing different tasks all within the same script. So it's kind of its own language, how you would think of C or C++, Java. Those are all different languages too. And then Unix itself has just led to a lot of different standards within the computing industry. regex or regular expressions is one that I often think about. It's like a format for how you can match. Typically, you're matching strings, so you can specify some different characters and a pattern that you're looking to match, and then go through data to find everything that matches that pattern. And another kind of, I don't know if it's necessarily a standard, but another idea that really came about because of Unix was the idea of having software modules. So being able to design your code or your programs to have small core modules that are accomplishing smaller tasks. And then you can combine those different modules in a variety of ways so that you're not duplicating the effort or the code to accomplish the same task like over and over again. You can reuse that and just combine it however you're looking to. And then lastly, why would you want to ever use Unix? I know that's something that when I was first learning about it in school, I was like, I don't really know what this is. I guess I know what Linux is, but just seems like something else I need to learn, so why would I care? But it's really good for multitasking. It's also kind of neat, the multi-user aspect of it as well. Usually, if a machine is like based off of Linux or Unix, you can have multiple users that are logged on at the same time versus like a Windows machine where only one person can be logged on. So that could be helpful for like a lab station or a shared computer in the workplace. That's useful so multiple people can use the same resources. It's very customizable, versatile. If you haven't caught on by now, people can kind of do what they want with Unix-based setups. So a lot of people create little shortcuts or handy things to make their computing life easier. And then the other really big thing is that there is just overall less burden on the system to run the operating system compared to Windows. So since it's taking up less resources and not being as taxing on the machine, you can run things faster, which is generally a good thing, especially if you're dealing with large sets of data with like the cloud computing. You can manipulate that data, take it in, try and figure out whatever you're trying to figure out with it. Do that a lot faster on a Linux-based system. And then the last thing is there's typically tends to be better security on Unix-based systems. Part of that is because Linux, when it came about, it's open source and it's free. So it's a lot easier for people to develop, and that kind of goes in hand with discovering more bugs within code and being able to kind of distribute the fixes for them faster. So just overall more secure from what I've seen so far. So the next thing that I was going to do is kind of do just a basic follow along or tutorial of some Unix commands that you can do. Before we do that, does anybody have any questions so far?
Someone asked a good question. Said if this is considered an in-person interaction with Qualcomm, yes, you can put that as an on-site event at university. Just because normally this would be on-site, but since
yeah,
we cannot.
as on-site as will be.
Yes.
Okay, cool. So let me stop sharing this screen, exit out, and navigate over to my other one. So if you have a Unix or like a Linux command line that you can access easily, definitely feel free to pull that up. If you don't, I'm going to send a link in the chat that Mia had shared earlier. It'll take you to a website where you can run a bash shell, so you can try out some of the commands for yourself. So that's kind of cool. And then, there we go. And then I'm also going to try and share the file that I am going to work with in the chat. It's just a list of names, so you can also just type your own list of names or whatever. It might not let me send it, navigate to the right place. it doesn't look like it's happy about it. So I just have just a basic text file, so you can upload that if you would like to work with. So let me go ahead and share my other screen. So over here, I have just a bash prompt. So that's bash is what my Linux shell that I use at work, that's what it's configured to run with. And right now it's in my root directory. So you can see that with this little tilde. So
we can't see your screen right now.
Oh, sorry. Let me
And one thing I would like to say, everybody, if you have not experienced command line interface before for shells, you start to learn this stuff in CompOrg 1, which is CS 2505. So I highly recommend following along at that link just to get some exposure to it if you haven't had that course yet.
Yeah, even you can see it now, right?
Yeah, can you zoom in at all? Just small.
That's a great
Usually
question.
Control plus does it for me, I think.
Let's see. Doesn't seem like it's working. Oh goodness.
That works.
Okay. Hopefully that'll print out okay. Sorry, we're normally Teams people compared to Zoom, so I'm not as familiar with that interface. Hopefully that'll print out. If not, I'll make it smaller. But the commands are also in the slide deck that you guys received. So if you have any other like issues with them or just want to look back at them later, you can always do that. So like I was saying, this is just the command prompt that I pull up for the machine that I usually work on at work. So it's running in bash. And right now I am just at my root directory. That's why it's a little tilde. So if I do ls, you can see it prints out a whole array of different files, like config files that set up things, as well as some folders. So then I will move to the folder where I have the tutorial file configured. So cd stands for change directory, and that's a command that you can use to navigate through the different folders that you might have, all starting from the root. And one thing to note is that if things are at different levels, you have to specify them. So if I wanted to go from like workspace builds into a folder called like test, or if I wanted to go to a folder called test that's just within workspace, first you'd have to navigate like back up out of builds into another folder. So within this folder, if you do ls, that will print out the different files that you have contained in this folder. If there's any subfolders within it, those will also print out. And then it also shows you like the permissions associated with the file. So that's all of the read, write, or the RWX that you see there. And those stand for like read, write, and execute permissions. So let's see if there's some questions maybe. I don't know where the chat is. Maybe TK can help monitor the chat to make sure everybody's staying okay. So I have this names.txt file, and that's what I'm going to be working with. So it's just a list of names, and to be able to actually see those names, I'm going to use the command cat, and that will display the contents of a file out on the command line. So now you can see here, yeah, it doesn't work very well, but now you can see I just have this list of names, nothing super special, just people I came up with. So have that in the file. Now what I want to do, I'm going to say, oh, I want to count all of the names that are here. So to do that, I'm going to use the command WC, which stands for word count, and then use the flag. If you've ever seen some Unix commands where they have a little dash and then another letter and then some other like characters, the dash and then whatever character, that's usually called a flag. So I'm going to do word count -L, which means I want to do the word count of the list of what's ever in this names file. So we do enter and see that there are 23 names. So if you look up here, I also have, it's not in alphabetical order, And there's also some duplicates, like I put 2 Katies in there and 2 Emilys. So this just really is telling you some pretty basic information about the file. So now if I wanted to go in and actually sort the names, say if I wanted to sort them in alphabetical order, well, lo and behold, there's a command for that. So you can use sort and then specify your file. So then once you do that, it will sort them all into alphabetical order. Pretty easy to see because I had a good subset of names here. So we have that. So something else that is pretty cool about using like Unix commands, Linux commands is a thing called grep. So it looks like that, G-R-E-P, and it relates to regular expressions. So using grep will let you return all of the strings, in this case their names, but let you return everything that matches a particular pattern. So I want to return all of the names that have the character A in them. So I'm going to use the grep command to do that. And I'm going to say grep, specify the pattern that I'm looking to match, which in this case is just the character A, and then my file. So there you can see that it prints out all of the names that contain an A, also highlights them, which I think is helpful. So that's pretty neat. And a flag that you could add to grep is the -v flag. So you could say -v, which is going to invert whatever the command is doing. So in this case, it'll give me all of the names without the letter A in it. So just another way to manipulate the data that you have in your file. So far, what we've been doing is looking at to see what data is in the file. But if you've noticed, every time it just prints it out to the command line, which is great if you just want to like look at it. But if you want to actually be able to reference it later, which I'm guessing in most cases you probably would, you are going to want to redirect that output into a new file. So the way that you do that is by using this little arrow guy. So I'm going to say, I'm going to use my same grep command here to get all of the names without A, but I'm going to specify that I want to put them in this new file called without.a.txt. So this isn't a file that I've ever created before. It's not in my workspace or anything right now. But once I do this command, if I ls and print out what's in my directory, now you can see without A is there. So that's pretty cool. And let's check and see if it actually did what we wanted it to. So I'm going to use the cat again just to check the contents. And looks like it's all of the names. Actually, I don't know why Akil is considered, oh, it might be case sensitive actually. I forget it. I'm guessing it'll be case sensitive, and that's an uppercase A, so that's why that shows up. So redirecting is really helpful. In this case, it's kind of a silly example, but if you were working with a lot of like really big files and you wanted to find, like say you had a list of like a whole bunch of addresses and you wanted to find all of the addresses that contain like Virginia in them, you could output all of those addresses to a new file and then have some program that you looked at that new file and sent everybody like an email from the data in there. So that could really help kind of simplify that whole process, and you don't have to manually go in and sort and look for all of the addresses yourself. You can use this expression matching to simplify the process. So another thing that kind of goes along with that is the idea of combining multiple commands. So that you can do with a pipe. And the pipe character is just this straight line. Normally I don't really think about it on the keyboard, but it kind of looks like a pipe. And that's going to let you combine multiple commands together. So if I use my same grep command as before, so I grep A to get all of the names that contain an A, and then I'm going to add the pipe to say that I want to combine something, and I'm going to combine it with the word counting. So I want to say, find all of the names with A and tell me how many there are, because I'm too lazy to count them myself. So once I do that, it tells you that there are 14 of them. So again, pretty silly example, easy enough for me to count to 14, but you can kind of see how this could be really powerful for those more complex operations that you're doing. So the last thing that I wanted to share with you guys before we move on to the optimization was how to use those regular expressions with something a little more complicated than just a single character. So I'm going to go back to my trusty grep command, but now I'm going to add in some new characters to what I'm looking to match. So I'm going to look for A asterisk L in names. So what the asterisk will do, it's really helpful when you're working with the regular expressions. I recommend pulling up a table online that will help you remember what all of the special characters do, because I certainly can't remember them all of the time, and it's good to have some examples when you're working with it, because they can get kind of complicated. But what the asterisk does is it will look for any instances that have 0 or more of the characters to the left of it. So in this case, I'm going to return any names that have, they might have an A, an instance of an A, or not, but they will have an instance of an L. So you can see here, it highlighted all of the L's. So how I wrote it, kind of just the same thing as searching for just a single character, but there could be an option to have an A there. So another thing that I could do is use the same A and L, but I'm going to put a dot instead of an asterisk. So, oh, that's actually a different input or output than I'm used to seeing. Oh, that's because I didn't type the full command I was expecting to. And if you up arrow in the Linux command line or the Unix command line, that'll pull up the last command that you looked at. So that's helpful so that you don't always have to type the same commands over and over. You can use like your previous history. So that's helpful. So when I do A.L, that's going to say the dot means that there can be one or more characters in between the two that I've specified. So you can see it returned names that had at least one. I didn't have any names where there was more than two, but they each have a letter in between A and L there. So just another more complicated way of doing some pattern matching. And then lastly, I was just going to show the same A.L, but now I'm going to combine the dot, the period, with the asterisk. So what that'll do is it'll find me all of the names that have the A and the L kind of as bookends for the pattern that I'm looking for, but then it'll give me the names that have one or more, but it could have way more than one or more characters in between. So you can see that gave some different results than just the typical A.L that we had tried before. So that is just some really basic stuff. I know I kind of went through it pretty fast. To be honest, I am nowhere near familiar with all of the commands that are available in like Linux or Unix. There's tons of them, and I found that just kind of as you go through and experience these things, you'll probably get really familiar and comfortable with the ones that you're using for like class or for an assignment or whatever project you're working on. So you'll learn those, and then eventually you might be ready to like do something else, and then you'll go and learn the command that you need to do that, and it just kind of builds upon that, and you're definitely not going to know like everything right off the bat, but don't let that keep you from getting started with working on some projects with it. So does anybody have any questions right now? No? Cool. I'll go ahead, see if I can stop sharing my screen somehow. I'll stop sharing my screen and let TK take over, and he will pick up with the rest of the PowerPoint.
Thank you so much, Katie. Let me share my screen. Can you guys see my screen?
Yep.
Cool. Let me just make sure I start on the right slide. Yep. Okay. So going forward, we're going to be going into multiprocessing and multi-threading. Basically, these are just ways of optimizing your code to make it run faster or smoother, depending on the type of situation or the type of code you're trying to run. And this goes hand in hand with Unix because Unix is designed basically for parallelization. A lot of big processes by many big companies happen in Unix, and they happen in parallel with each other. So this is just going to be a basic overview of how those sort of systems work. So first, we're going to go over multiprocessing. And multiprocessing is really just the act of running multiple processes on either multiple CPUs or multiple cores in a CPU. This does allow for a good amount of speed up just because you're able to utilize the full extent of your CPU by running, or your multiple CPUs by running them concurrently. Because in most processes, if you don't parallelize them, then it's going to be running on one core or one CPU, and you're going to get a lot of slowdown if you just run everything serially rather than parallelizing them. Earlier versions of computers only came with a single core CPU, and as time went on, people started adding more CPUs to a system or a server, and that's how they gained the power. Then the advent of adding cores, a multi-core CPUs came in. So in a multi-core CPU, each core pretty much acts as its own individual CPU controlled by the main CPU that orders the instructions that are generated by them. So just a little history in terms of how this developed. And as you started getting more cores on more CPUs, more cores and more CPUs and just more CPUs in your system in general, you're able to save a lot on space and time, because having more cores on a CPU physically when you're designing has a lot of benefits in terms of heat, energy output, and things like that, as well as the amount of space it will take up, a number of pins it needs to connect to the board and all these other things. So that's why there was a big move to going towards multi-core CPUs. One of the big downsides for multi-processing, though, is that it allocates a separate memory resources for the processes that are generating. So rather than multi-threading that we're going to talk about in the next slide, multiprocessing does not have a shared memory space or shared resource space for each new process that's instantiated. So the next thing is multi-threading, and this is also the act of running multiple tasks at the same time, but it happens on the same CPU. So rather than being spread out across the multiple CPUs that are available, this all happens concurrently on one CPU. Since it's all done on one CPU, the major benefit that comes from it is having a shared resource pool and a shared memory pool. So we'll go over this in the pros and cons on the next slide, but with the shared resource pool, you're able to basically use the same variables within them without having to duplicate everything over and over again. And even though it is considered parallelization in a way, it doesn't actually happen in parallel. It's more of concurrent programming. So there's a difference between concurrency and parallelization. With concurrency, the processes are sort of intermeshed together. So the CPU goes through the process of breaking down the different instructions that are required for your thread, and then each thread is sort of sewed in one after the other. So they're actually happening consecutively and sliced up in a way that is more efficient for them to run in many cases than running them serially would be. So it's truly not 100% parallel, but it's concurrent with each other. So going over the pros and cons for multiprocessing, the major pros are it takes much less time to run through something going through multiprocessing. Since it's running on multiple different CPUs and each CPU is dedicated to running this process, it will be much faster to actually run through the process. The other benefit of this is you can also see all the processes as they are all spawned separately. So it's easy to interrupt them or kill them if one of them is going bad, or just interact with them in any sort of way. And also multiprocessing is really good for processing large amounts of data. Again, because it is much faster, utilizing every single CPU or every single core that's within your system. The pros of multi-threading are pretty much whatever is not good about multiprocessing. The shared resources in multi-threading are a very big benefit. This allows for less complexity when you're trying to work between multiple threads or multiple processes. Being able to share in multiprocessing systems, since you're not able to share resources, you have to go through this process of messaging whatever variable or data you want to share back and forth, and that adds a little bit of overhead, makes the whole program just slightly slower. So having that ability to just have that shared memory space is very beneficial. Again, no need to message between the threads. And the other great thing about threads, because you don't copy all the resources like multiprocessing does, it's very fast to create them and manipulate them. So if it's a very quick program that you're trying to run, it's going to be easier to multi-thread it, because there's a lot less overhead in creating the new threads than there would be in creating the process. The cons of multi-processing would be that they're very time and resource intensive to create. Even though they run faster, they take a lot more resources to create because of the duplication of the resources. The cons of multi-threading are they can take slightly longer to run through. Again, since they're not really parallel, but more concurrent. And so they're just being sliced up and being run on a single CPU. And it's also hard to identify the child tasks, again, because they're not their own separate tasks. They're really being pulled in as one task. And that one task is happening, it's just switching back and forth between all the different tasks much more quickly. So those are the pros and cons for these two things. Now, it's good to look at the different considerations. These different considerations when deciding how you're parallelizing your code and whether or not it's worth it. So the first one is looking at race conditions. So with race conditions, when you have a shared resource, you could have multiple threads trying to get to that resource at the same time. So you need to make sure that they're accessing that resource in the order you want them to, as well as one isn't overriding the work of the other. And then this leads into the idea of mutual exclusion. So when you have this sort of shared resource, you want to make sure that only one thread or one process is acting on it at a time. So you add sort of locks around that area that's being used, and make sure with those locks, the first thread that reaches that will activate the lock. Once they activate the lock, they're able to handle the resource as they need, and then once they're done, they can unlock it afterwards. Other resources, once the first resource locks the resource, once the first thread locks the resource, are unable to access that resource until the thread unlocks it right afterwards. This could cause issues such as deadlock if your initial thread does not end up unlocking it in a timely manner. So that's one of the things to just keep in mind whenever you're trying to use locks in your threading system. The other thing to take a look at is bottlenecks. So there are many points in the code in which you could have a bottleneck, as in there's a portion of, even though your code is parallelized, it seems to be stuck on one portion of the code for a majority of the time. And this could cause major slowdowns if it's not possible to handle that in any other way. So looking for those key points where the code may be lasting longer than it should, seeing if you can also parallelize those sections or move them in a way that could more effectively work with the structure of your code. And then this would also lead to sequential consistency. And with sequential consistency, it's basically the idea that your code runs the same when parallelized or when not parallelized. So there's no benefit for you parallelizing it because it would take you just as much time or more in some cases to go through the parallel method than it would to just go through the regular serial method. And there are many reasons for that, as I can go over as I do the demo itself. But before I go into the demo of all these things, does anyone have any questions? Okay, let me open up this. So in this demo, I have basically a program that will generate a file that has random numbers in it, a certain number of rows and columns. So in here, we have a row count, column count, and this is a Python script. So the reason I'm using Python for this one is to demonstrate multi-processing. Python has a pretty good multi-processing system, and it's much easier to utilize than, let's say, C++ or some other languages. And with Python's multi-processing system, you can easily spawn new processes, especially in Linux. It's very useful. I'll be using the Linux terminal on the left side over here. Python, this is another thing when talking about considerations for what you're using. It's also dependent on the programming language and operating system. So with the programming language here, Python's multi-threading system is actually not that great. So in many cases, and most cases when I was running through just this sort of test code, it actually ran worse to do it multi-threaded in Python than to do it serially in Python. And this could be attributed to the efficiency in which both Python and the operating system run the program could be more optimized than what you're doing with your current threading system, but also overall Python's threading system is not that great. So in this code, you'll see that it has two different sections. I'm gonna start them up because they take a couple of seconds to run. So with this, you'll start off with the serial code, and all that it does is it opens up the output file in this logs directory, and then it iterates through the row count and column count, and then it just generates a random integer between 1 and 20, and then it appends that random number to an array, and then after each row, it'll print out those lines to the terminal or to the file that was open before, and then it'll clock the time for that. So this would be the serial approach, just one thread basically going through and running the entire thing that we're trying to do. If you go down to here, you can see the multiprocessing approach. And what Python has that's very useful is has this pool function. So you can pool and create all these separate threads. And these threads can be mapped to a specific function for however many cases that you're trying to run them for. So over here, we pull and we have 5 different threads running at the same time. And then the output is going into this parallel output file. And what happens here is this goes and maps it to this function over here. And then this function only does as many rows and columns as is necessary for that thread. So since there's 5 threads and there's 5,000 columns, each one is doing 1,000 columns basically. Then over here, or in this case, it would be 1,000 rows each. So then the processing of the data is the exact same thing. It will create a random number between 1 and 20, and then it will append that number to an array and then write those lines. So you can see this is called over here. And as you can see from the results over here, when you're running the code serially, it takes about 58 seconds to run through for these 5,000 by 5,000 numbers as to generate and write down. Versus if you pull all the functions or all the threads together and run it parallelly, it takes around 14 seconds. Also, you do have to go in and combine the files afterwards. So like I said, since this is multiprocessing, you cannot share resources between the different processes. So what ends up happening is when you're processing the data in here, you have to create a separate file for each one of those. And then once you have all the files created at the end, you can combine them afterwards. So this whole time period was the time it took to write all the values to those separate files, as well as the time it took to combine all the files and then remove the files afterwards. So this is one example of how it would be useful to parallelize your code and make it faster. Over here, I have code in C++. So for this code, it does the exact same thing. You'll have you have rows, columns, and then a serial and parallel process that goes through and tries to create that sheet. So you can see over here, same thing, serial process and the parallel, and this one is going to be multi-threaded. So let's quickly create this and start it up. So in this, it would be about the same process as it was in the Perl code. But as you can see soon over here, it actually runs faster because we're using C++, and C++ is a compiled language, and it's just going to be faster in general. That took four times as many outputs that I had to give. The serial process took about 22 seconds. And you can see the multi-threaded process runs in a similar way as the multi-processing process that happened in Python, where you have a list of the different threads. Then you go through and iterate in C and create this mapping between the thread itself, the function it's going to call, as well as this is the output file it's going to output to, and then the thread count. So the big difference over here you can see is that you have this shared resource space, and because you have this shared resource space, you have this output file that you can share between the different threads. And so everything is writing to the same thread rather than having to write the separate files and then combine them later. So again, that's the good thing about having the shared resources. Second thing you can see, because you have a shared resource over here with this output file, you have to apply these locks. These locks basically tell the different threads whether or not someone else is already in this safe space. And if there's someone else in there, then they cannot go in and change anything in here. And they have to wait for the lock to unlock, then they're able to access the thread. So a lot of people ask then, why not just parallelize everything and just always use parallel code? And you can see from here, this would be an example of a situation where the serial process took 22 seconds, but the parallel process took 37 seconds. And if you were to extend this to any length, normally some people would think, oh, maybe it's just because it took a long time for the threads to spawn. So if you have more data, it could catch up. It could be true for large sets, but even if you were to make this 10 times larger, the serial process would still run faster than the parallel process in this case. Now, I want to throw out a question to anyone. You can either write it in the chat, or if you have, you can speak out. I don't know if people can talk, but could anyone identify like why this is, I can put them side by side, why the multi-threaded process took longer than the serial process? So here's a serial print. You go through, open the file that you want to write to. For each row, you create your vector that you're going to store everything in. Each column, you create your random number, convert it to a string. This one is just from 1 to 10 or 0 to 10. And then you push that into your array. You combine all those with commas, and then you print out that to your file. Then you close the file. So that's the serial process. While the parallel process does the exact same thing, but each thread is basically just doing this for its column count, pushing back a random number, and then joining them. Does anyone have any ideas as to why it's running slower? I also don't know if I can open the chat. If someone messages something in the chat, let me know.
We have one question. Could it be resource contention or context switching?
Yes, it would be resource contention in a way, but what resource? Like he said, I'm not great with Zoom. I'm so used to Teams.
We tag team it.
Yeah. Anything?
No. The
So,
mutex?
The mutex, that's a good thing to point out. So if you were to remove the mutex locks, you think it would run faster? You can test that out. I will let you know right now. The mutex locks aren't the part that the mutex locks aren't the part that are actually making it run slower. So you can regenerate that. Actually, we can even skip the serial portion. And the mutex locks, though they do add a bit of overhead, they don't overall add enough to make this sort of time difference in the speeds. I'll let you guys know. The issue is actually with this RAND statement. So the way RAND actually works is not thread safe. So that's one of those things where it becomes a bottleneck for the code, as most of the time the process is, you can see it still took 33 seconds. Most of the time the process is still trying to use a commonly shared resource inside the RAND function. So this is something that would be hard to tell just by looking at the code. But if you do research into the time profiling, you will see that most of the time the code is spending is inside that RAND function, and it's really locking up the entire system. So as just a quick example of this, if you were to remove that RAND function and just run everything with the number 1, I still need to add this back. You can see that both of them should run faster because overall they're both not using that RAND function. But in this case, the parallel process should run faster than the serial process. Another thing that you can see over here, it took 11 seconds to run the serial process, and it took 2 seconds to run the parallel process. So those are the sort of considerations you have to see. And even though that RAND one is very particular, there are many situations where you'll have pieces of code that aren't well optimized for what you need to do in order to parallelize them. So you need to see all the aspects of it and see whether or not it's worth it to parallelize or not. In this case, if you had to use that rand function and there was nothing else you could use, then it would cause major slowdowns. It would be better for you to serialize your code. Going back to the idea of sequential consistency, it's not worth, you don't gain as much just because of the fact it's parallel. You have to go in and test that as well. Other things that normally show up as different bottlenecks are input-output. Input-output takes a long time to go through, especially if you're writing to the hard drive, rather than just storing it all in memory. So shifting the way you do your input-output could change the way the serial data will go. Like in this case, I have it that for every single row, basically, you're outputting, versus this one, you combine all the different rows generated by that particular thread. And then only after you have those all stored in memory, then you can output. This could give you a speed up because you're not doing as many IO related tasks. So even just parallelizing isn't enough. You have to go through and see what portions need to be parallelized and why, and if it's necessary, and how to even optimize the sections that are parallelized to make it work better in a parallelized system. Go back. Does anyone have any questions on the examples or anything I gave out? So that was the basic overview of how multiprocessing and multi-threading works. Now we're just going to go into a couple of different trivia questions. If people were, oh, that's how you get to chat. If people were paying attention before, we can see it now. So I'm going to go into a mini trivia challenge. I think Katie can help me pinpoint whoever answers the question first on the chat.
Yeah, if you guys just want to, when you get the answer, if you just type it in, and then we have a few prizes. So whoever gets the question right first in the chat will be the winner for said question.
Yes, and all the questions are lettered, so you just have to do A, B, C, whatever. And the first person to respond correctly will get the prize. You cannot just type in every single letter, we will know. And first question. Which is faster to create? A new thread, a new process, or they take the same amount of time? Do we have an answer?
Not yet. We have a new thread.
A new thread?
Mm-hmm.
That is correct. So between a thread and a process is faster to create, but a process is faster to run. As in, it will run through your code much quicker than a thread is because it's on its own core or own CPU.
We also have another question too before I forget and we lose it. What is the best way to learn this on your free time? Do you have any tips?
Honestly, I normally just go online for most of my learning. There's a lot of resources online for helping you with multi-threading and multiprocessing. We can give afterwards, like I can send out a few links that can go over the basic ideas of how multi-threading and multiprocessing works. But most of the time, I think for coding especially, researching online, getting the information from there, and trying to understand how it works for the different, again, languages you're working on, because it is very varied depending on the language you're using, as well as the operating system you're working on. There's certain functionalities that don't work on some operating systems as well as others. Some things work better on Linux than Windows, or any sort of mismatch of that. So there are a lot of resources out there, and I could go ahead and send those to you guys later for what I normally use for looking things like this up.
Yeah, and I think too, just like picking a basic example, like here we are just printing numbers to a file. which seems kind of trivial and may not be like the most fun thing to say, like I made a project that prints numbers. But if you have like a basic idea that you can start with, so that you can focus more on the learning with like the in this case it'd be like the multi-threading or the multi-processing, so you can focus more on learning that and don't necessarily get overwhelmed with what you want the multiple processes to do. I think that can help to kind of isolate what you're trying to learn.
Mm-hmm. Anything else before we go on to the next one?
Nope, that was all.
Okay. How do you return all the names with a particular character? A, grab-i, a names.text. B, grep-iv, a names.text. C, return-iv, a names.text. D, group-iv, a names.text, or none of the above.
We have a B, but that's not the right answer for this particular command. D, not quite. A, not quite. We're going to do process of elimination here.
We'll make it through all of them at some point. There's 2 left. Who's going to guess?
Now there's only 1 left. Yeah, E. Go team. Yeah, so the little bit of the trick here was all of the other, well, some of these aren't actually commands. So what would have been a close answer would be B, which is the grep. So that would have gotten you the results related to a particular character, but since that -v flag is specified, that inverts it, so that'll give you all of the names without that character. So that was kind of the trick here. So none of these will actually just give you the names with an A.
Then the last question, what is a bottleneck? A, when sharing a resource, it is necessary to ensure that the work being done on one thread is not necessarily undoing the work of the other thread. B, occurs when a portion of the parallelized code effectively takes up the majority of the time and cannot be easily parallelized. C, the use of locks around resources to help mitigate any race conditions by allowing the resource to only be used by one process. Or D, none of the above. Remember, answers get prizes. We will be sending out Qualcomm swag to all the correct answers. Any guesses?
Not yet. Oh wait, there was a B. Sorry, I missed it.
Yes, the right answer is B. It occurs when a portion of the parallelized code effectively takes up majority of the time and cannot easily be parallelized. Like I was showing before with that rand function, you can have bottlenecks that cause it to sort of be less efficient to run things in parallel than it would have been to run things in series. So yes, it's important to take note of all the bottlenecks and all these other different considerations I listed above when looking at parallelizing code.
Sweet.
Okay, that is all of our presentation. We just want to make sure you follow these steps, complete that Jumpstart page, Jumpstart profile. Again, if you were unable to do that, I sent my email in the chat. Feel free to email me your name and email, and I'll get that to our HR people. And of course, feel free to apply for all these different opportunities that we have for our internships. We have one of the best internship programs I've ever been a part of. It was one of my best summer memories ever, coming down here to beautiful San Diego and then exploring and just having fun with all the other interns around here. It's a beautiful place, a lot of nice people. And also for new college grads, there's positions open. We're looking for more and more people, and we're constantly hiring. So feel free to shoot us your resume through that link listed on this page as well.
And I think too in the PDF slides that you guys will all get from the meeting, these links should work too, so you can go and read about the different like individual opportunities if you want to have more details about them.
I just want to thank everyone for coming out tonight, taking the time out of your busy schedule to be here. Shout out to Katie and TK. Thanks for really great workshop. Really appreciated it. We have more events coming up this semester, Capital One and Bloomberg and IBM. Feel free to check them out. Katie and TK, would you be open to answering questions for like 10 minutes or so? Do you guys have time for that?
Yeah,
Sure.
definitely. And you can ask about like the technical stuff, where you can ask us about like working at Qualcomm or what do we work on, basically whatever classes to take while you're still at school. I don't know.
Sounds great. Feel free to unmute yourself or drop it in the Zoom chat, whatever works best for you guys.
And be sure to fill out our end of meeting raffle form. I just put it in the chat, and you can win a $10 Amazon gift card. I actually do have a question.
I was gonna say, we answered everybody. Wow.
So I'm a senior and I'm going to grad school at Tech next year. And systems was a really difficult class for me. I found it hard to visualize, all the threads running. I'm like, where is this lock happening, right? Is it as tough of a job like the embedded software systems jobs for computer science majors? Or is systems a bad representation of systems programming?
I think, in my opinion, systems does give you a lot at once, and a lot of the tasks that you would probably do in systems are spread out across either multiple people. So one thing always to consider when looking at actually working in industry or anything like that is, rather than having to do everything individually, you're working with other people. People will help you out and sort of point you in the right direction. And also in those industries, you have industry leading tools in your work that you're doing for your class. I'm sure their goal is to try to teach you how to manage these on your own and things like that. But we use things like Clockwork or other tools to sort of manage and keep track of like overflows, or it can help you track down a lot of these things much more easily. So it's easier for you to debug, because we're not trying to trick you here. We're just trying to make sure you output the best thing you possibly can. So a lot of the manual work of trying to sift through your own code is sort of mitigated with that.
Okay.
Yeah, and I think too, like, I guess personally, what I work on, I don't like it is running. There's multiple processes and like threads and stuff going on, but it's not necessarily like I am writing all of that code myself. Kind of like TK said, we're using tools, but also if there are issues, kind of just in the general call flow, I always find that it helps, like talking with somebody else about it, because there's always going to be somebody that's like more senior than you that you can ask for advice or is more familiar with the code. But also just drawing pictures is like really underrated, I think. So just kind of writing out, like, you don't have to write out every line of code, but kind of writing out the blocks of the different steps and seeing like, oh, it wraps back around here in a way I didn't think about before. That can kind of help you troubleshoot the stuff too. So that's something I do a lot.
Okay, thanks.
Any other questions? We have a lot of answers for if you're interested in interning. We both interned. If you have questions about the work experience itself, you can also let us know.
I have a question. So I actually interned at Qualcomm, so I had a question about internship. So jumping from intern to full-time, what made you decide to go back and realize, okay, this is a place for me to work full-time?
I guess I can start. So for me, well, I really like the Boulder area. So that was definitely like a big consideration for me. because I wanted to be able to enjoy the work, but also like feel comfortable in the place where I was living and know I'd have like activities and stuff that I would enjoy doing. So that was really important. But I think the big thing for me about Qualcomm in particular was just the people. Everybody that I've worked with has been like really open and really willing to help you like figure things out. And I've never felt like silly for asking questions or like I was asking too many questions or anything like that. So I think that's really important because I know it's something I tend to worry about. Like, oh, I feel like I should know all of these things right off the bat. Like how, but there's no way that you could know them because you haven't done any of this stuff before. So I think that was one of the big things. It's just really the people and like the community that's here. They really take care of the employees. So
Yeah, mine is about the same in terms of I love the people here that I've met. The internship program was very good at getting you to know people, and a lot of the people I interned with, I still talk to right now that I'm doing full-time work. And also the work was very interesting to me. I did my undergrad in computer engineering and electrical engineering, and then my master's was specifically computer engineering with a focus on embedded systems. And so I enjoy the work of low-level software, which is what I get to do right now. Their matching is pretty good in terms of your interest to the team you get paired with. And just San Diego in general is beautiful. So interning in San Diego just made me want to love it and come back.
Thank you so much. That really helped.